Good morning, students. What is the yesterday session of your class we have done, beta? We are defined up to the Newton's second law, momentum, and components of your forces. Picture. Am I audible, beta?
Yes,
Yes,
sir.
sir.
So yesterday we had just started with Newton's laws of motion, and we have discussed the different types of your terminologies in that one. We talked about inertia, different types of your inertia. Then we talked about your Newton's first law, second law, and as well as of your second laws, application and derivation of your force. So I hope everyone is clear with the derivation of the force. F is equals to how much for me? M into your A, or F is equals to M into your dV by your dt part of relation. And different components of the forces also we have done right now there. Clear for everyone? Sure. Let us try to go for the next one. That is about your Newton's third law. Newton's third law. I hope everyone knows the Newton's third law. From your school days, you might have been coming across that one. What is Newton's third law, beta? To every action, there
For
is an
every
equal
action,
and
there is equal and opposite reaction.
opposite reaction. That means whenever one object exerts a force on the second object, the second object also exerts the same amount of the force on the first object. So I can write here right now, whenever one object exerts a force on a second object, comma, the second object will also exert also exerts a force on the first, so the two forces are in opposite directions, beta. The two forces are in opposite directions. This is very important to be remembered, beta. The two forces which are been acting are always in the opposite directions, but they have equal magnitude. But they have equal magnitudes. Clear? So whenever one object exerts the force on the second object also exerts the same amount of the force on the first object, whether it is moving or not. Let's say, for example, when you exert the force on the wall, the walls also exert the same amount of force on you. That is the reason you are not able to push the wall. If your force is greater than the force exerted by the wall, then the wall can be breakable. Then that is the reason that wall is getting break. Otherwise, if your force is equal to the reaction force of your wall, then there will be no net displacement of the body particulation. So in one terminology, I can write this one as a fever. To every action, there is an equal and opposite reaction. there is an equal and opposite reaction. Clear? This is your Newton's third law of particle relation. That means if an object A exerts the force on object B, the object B also exerts the exactly oppositely directed force of equal magnitude on your A. So this law is about forces between objects beta. It says that any force always occurs in what? Pair. It says that forces always appear in pair or occurs in pair, what it means. Okay, so the force on the third law pair is action of another body, so they cannot cancel to give a resultant to be zero because they are acting on two different bodies. The force on any object A or B may be called as action, and that of the other object will be called as a what? Reaction. If one is an action, opposite will be your reaction. Like say hitting of a 6. Hitting by bat is nothing but what? Action. Reaction has been felt on the ball, and that is the reason it is going on other direction. So that is about your Newton's third law. So Newton's third law says that for every action there is an equal and as well as of your opposite reaction, and they are having the equal magnitude, but they act on two different bodies. That is the reason the net force acting on any of this body will never be equal to your zero. It will never be equal to your zero particle relation. Is it clear for everyone? Is it clear for everyone?
Yes, sir.
Chalo. Let us try to talk about the first force to be remembered in this one. That is about your normal force. First one is nothing but of your normal force. Normal force is nothing but of your the force which the surface will exert on the other. I'll say we can talk about a free body diagram before that one. So free body diagram is nothing but a body is represented by dot and each and external force is represented by vector. So if I'm talking about the normal forces right now, beta, when one surface, like say for example, this is your table. Sorry, this is your table. On this table, there is a block like this. Block of mass, say for example, M. Isn't it? So what I can do is I can exert the forces acting on that body. One is weight exerted by this body in the downward direction. That is nothing but of your mg. This is the ground. Ground will also exert the force on this body in upward direction. That force is called as of your normal. Clear for everyone? So what I mean to say is when one surface presses the other normal force acts on both the surfaces, both the surfaces. Okay, it is contact force, I can say better, which always acts at right angle. If there is no contact, there is no normal. It is a contact force. It is a contact force which act at right angles. Which acts at what, beta? Right angles to the surface in contact. Okay. Normal force is always perpendicular to. I can write one more point here. Normal force, whatever you are taking, normal force is always perpendicular. Is always perpendicular to the common tangent. Okay, to the common tangent which is being drawn at the point of contact. At the point of your contact. Okay, children, see here. If this is a block, mass of this one, this surface of this one is touching the ground. So ground is exerting the force on the block in upward direction, and block is also exerting the force on the ground in the downward direction. So this is the weight of the body which is acting on the ground, that is m into g, and the ground is exerting equal amount of mg in upward direction, that representing by your n part of a relation. So if I take an FBD of this one, I represented by your dot, this body. The forces acting on this one is nothing but of this is the normal, and the weight of this body is nothing but of your mg. This is your FBD of this one. FBD means free body diagram. FBD means free body diagram part of relation. Clear for everyone? And normal is always perpendicular to the surface which you see right now. Here it is making an angle of 90 degrees with the surface whichever in contact. If you even extend in the downward direction, it is making an angle of contact with 90 degrees. So normal force always acts perpendicular to the plane of surface at the point of contact. Plane of surface is a common tangent, and in given cases, whatever the conditions you write, you should always take normal perpendicular to the contact of your surface part of a relation. Is it clear for everyone? Is it clear for everyone?
Yes,
So
sir.
what is a normal force beta? When one surface presses the other, normal force acts on both the surfaces, and it is the contact force, and means this will come into play only when two bodies are in contact. If two bodies are not in contact, there is no force acting on the body. There is no force acting on the given body. Let me give you some examples for this one. Okay. Okay. So this is something like this. This one is say small m, and this one is say for example capital M. And this one is your ground. This one is your ground. Make an FBD of this one. What are the forces acting on this body? Let us try to talk about this one. On this one, there is one normal force which has been acting. Equal and opposite force, that is nothing but equal to your N1. And there will also be equal and opposite force acting on this one. This one is also your equal to N1. This is your block. Okay. Now see, these two are in contact here right now. So these two are acting on this contact. So this will exert the normal force acting on this body. So this will be equal to N2. And this will also exert the same amount of normal on this one. So this one is also your N2 because these two are in contact together. So this is pressing this body and this edge is also pressing on this body. The same way this edge is pressing on the ground. So this will exert one normal force on the ground. So that will be equal to how much right now? N3. And this exerts the force on the ground. So this force is also equal to N3. This one is nothing but say for example some rod. Are the forces clear for you? Are the forces clear for you? Let me try to draw the FBD of your block. FBD of your block. So what I'll do is I'll try to take the total mass to be concentrated here. So one is weight of the body which acts in the downward direction, that is nothing but of your M into G. The another force is in this direction, that is nothing but of your normal, that is nothing but of your N1. On this block, there is also the force exerted by this rod, that is nothing but N2. So N2 will exert the force on this one. So this is the direction of the force which has been acting on this one. So this is nothing but of your N2. Is there any other force which has been acting? This N1 and N1 are equal and opposite, so they'll get cancelled. So block of the block, weight of the block is mg. This mg is balancing your m1. So this n1 balances your mg, capital Mg, and this rod will exert the normal force acting on this body. Now second one is on the rod. This is nothing but of your small m. Small m weight also acts towards the gravity. That is nothing but of your m into g, isn't it? On this one more normal is been acting on this one. So that normal force is nothing but how much beta? On this rod, there is N3 which has been acting in the upward direction. And apart from that one, there is also one more force which has been acting on this one. Equal and opposite force. That is nothing but of your N2. So this one is of your N2 which has been acting on this. Is it clear for me? So this is your FBD of your rod. This is your FBD of your rod. This is your FBD of rod, and this is your FBD of your block. Is it clear for everyone? Any doubt? Please let me know.
No, sir.
Everyone got an idea how to draw the normal force?
Yes, sir.
Shall I give you some more examples?
Yes, sir.
So this is my first example which I have taken. I'll give you more examples so that you will become perfect on this one. So say for example, tell me what are the forces acting on this one? Which sides are pressing it? You try to identify that one. This side of this block is pressing on this one. So there will be an equal and opposite force on this one. So like say if this is exerting the normal N1 here, this will exert the equal and opposite normal on this one, isn't it? Even these two are in contact. So here also one more contact force we will be getting. So if I'm taking this one as somewhere here right now, you already got that one. Yeah. So if there is one force here right now, this one is nothing but of your N2. This will be equal and opposite force here right now. This will be your N2. Is there any other surface which are touching each other? I told you N should always be perpendicular to the surface. See that it always makes an angle 90 degrees with the surface whichever they are in contact. Clear for everyone? Got it?
Yes.
Sure. Take one more example and draw the diagram for me. Okay, I'll give something like this. Yeah. Okay. This is making here an angle beta, and this here it is making angle alpha. Now tell me which bodies are touching which one. This is some rigid body which is always fixed. A V-shaped type of a structure is being present. In that one, we are keeping a sphere. So in this one, I have kept a sphere right now on this one. Now draw the FBD for this one. I mean to say, draw the normal force acting on that one. Normal force should always be perpendicular to the surface beta. This part of this one, this is the center. This part is touching on this one. That means this is one contact. So this one contact is nothing but of your how much? N1. So this also exerts the same amount of force on this one. So this is also your N1, equal and opposite force, Newton's third law. And this one is also in contact with this one. So this is a new contact. So here it is nothing but of your N2, exactly opposite to this one will be equal to your N. Is it clear? Is it clear?
Yes, sir.
Chalo. This one is fourth one. Now tell me the diagram for this one. And please try to tell me the free body diagram for the given condition. Say, for example, I have taken something body like this. And this is your straight line. It touches here. And this is your another straight line which touches here like this. Okay. Then this is some contact right now here. It is a surface. A V-shaped type of a structure in which a sphere is being kept. And it is making, say, some example, some angle theta, what it means. Now tell me normal forces acting on that body. What are the normal forces? Where it is been in contact with? Where it is in contact, can you tell me? This is contact here and this is contact. These are only the two places where they are been touching. isn't it? So there are two normals which have been acting. This one is, say for example, one normal, that is nothing but N1. This will be equal to opposite normal. This is also your N1. If this is in contact here right now, this is your N2, and this also exerts one more force, that is nothing but N2. And this always act for the centric bit, what you call that, for the circular path towards the center bit, that you need to keep into the mind whenever you're drawing the conditions. Clear for everyone? Is it clear for everyone?
Yes.
Chalo.
Yes,
One
sir.
more. And you please try to tell me right now FBD of this one. Sorry. This is a, for example, ground. This is a block of mass M. This is a block of mass M. Now tell me, what are the normal forces acting on this body? See, if I take the M1 into consideration right now, this is your M1 and this is your M2. I'm drawing it individually so we'll get a clarity. Now tell me, what are the positions where they are in contact? They are contact here, they are contact in the ground. That means there will be one of the force acting on that one, that is M1 into G, and there is one normal acting on this one, say for example N1. And there is one normal acting on this one. This is nothing but of your N2. And weight of this body acts on the ground, that is nothing but M2 into G. Now, they are also in contact on this one. This will exert one normal on this one, say for example N. And this will exert one normal on this one. So this will be equal to your N. Equal and opposite forces are acting on this given body. So M1 will exert the force on M2. This is N. M2 will also exert the same amount of the force on your M1. If these are same, then only they will always be in contact with respect to each other. Is it clear?
Yes, sir.
Is it clear? I hope you got an idea how to draw the FBD, everyone.
Yes, sir.
चलो एक छोटा सा क्वेश्चन कर लेते हैं. Find the normal force. Find the normal force between number one, block and the floor. Block and the floor. Number two, block and the wall. Block and the wall. And third one is, okay, you take only this two and take G value to be equal to, G value is equals to 10 meter per second square. Okay, the diagram is given something like this. This is y-axis, this is your x-axis, and block is being kept in contact with this one somewhat like this. This is your 3 kgs of your block, and this one is your wall. This one is your wall, and this one is your ground. This one is nothing but ground or maybe your floor. Okay, now try to do it out. Can anyone give me the answer for this one? Find the normal force between block and the floor. Block and the floor. What are the forces acting by this block on the floor? One is weight of the body in the downward direction, and this floor exerts equal and opposite force on that one. That means if I'm taking this one as the weight of the body, this is the weight of the body, that is nothing but of your M into G. The floor will exert an equal and opposite force on that one, that is nothing but of your normal reaction, that is nothing but say N1. So for this one, N1 will be equal to your M into G. Mass is how many kgs? 3 kgs. G value is 10. So N1 will be equal to how much for me? 30 newtons. Isn't it? Force, normal force between the block, this block and the floor. That means between this block and the floor, this is only the surface where they are in contact. So this will exert whatever the force is exerted by the block on the ground or the floor will also exert the equal and opposite force on this one, isn't it? So N1 will be equal to your M into G. This is the FBD for the block part of relation. Clear? Now what is the normal force between block and the wall?
Same.
How much it will be? Is this block moving in the horizontal direction? Now see, if I am taking this one right now, this is your block and this is your wall. Is it? Now, whatever is the this wall will exert some force on this one. This wall also will exert some force acting on that one. This is N and this is N. This is N1, this is a N2, this is N2. Equal and opposite, N2 minus of N2. That will be equal to how much? 0. That means normal reaction will be equal to 0. Isn't it? So normal reaction will be equal to how much for me? 0. There is no acceleration acting on the system. So this one is of your N2 in the positive direction, N2 in the opposite direction must be equal to mass of that body into acceleration. So this is totally 0. That means this is N2 minus N2 is 0. So N2 is equals to your N2. There is no normal force acting on that body. So N2 will be equal to how much for me? 0. Is that point clear for everyone? Isn't
Yes,
it?
sir.
Whatever is the force exerted by the block, this 3 kg block on the wall will also exert the same amount of the force acting on that one. So when there is the same amount of the forces acting on that body right now, what I can write now for the given condition, tell me? Isn't it? So there is no acceleration in horizontal direction. So if there is no acceleration, force must be equal to mass into acceleration. Normal is nothing but a set of force only, na? So that force will be equal to mass into acceleration. Acceleration along the horizontal acceleration is 0. So N2 minus N2 is 0. So N2 is into gets cancelled. So normal reaction between the wall and the block will be equal to your 0. Is it clear? Clear?
Yes.
So I'll keep on point right now. We see. We always know that normal force act when two bodies in contact press each other. Okay, so normal force will act only when there are two bodies which are pressing each other. Now if I am getting the relation, if normal reaction is greater than 0, that means two bodies will be in contact. Two bodies are in contact. If normal is 0, that means two bodies are not in contact. Is it clear?
Yes, sir.
ये क्वेश्चन का आंसर बताओ जल्दी से. Find the normal force. Find the normal force between 2 kg and 3 kg blocks. Think and give me the answer. This is your horizontal floor. On this one, we are keeping a block. One is your 2 kg and another is your 3 kg. Okay, not what is the normal force between them? Normal force between them, that means this is the contact. चलो बोलो जल्दी से. Just make an FBD separately. एक 2 kg को separately draw कर लो. कैसा करना देखो, 2 kg और 3 kg को separately draw कर लो. पहले separate कर दो. ठीक है ना? ये इस पे फोर्स एक्सर्ट करा था बोला मैंने, तो ये इस पे एक्सर्ट करेगा एक फोर्स इक्वल पे और ये भी इक्वल पे. तो ये जितना फोर्स एक्सर्ट करेगा यहाँ पर भी ये भी उतना ही फोर्स का एक्सर्ट करेगा. दो ही तो कांटेक्ट में रहेंगे. बट इट इज नॉट प्रेसिंग दिस वन, क्योंकि मोशन नहीं है ना, खाली लगे रखे हुए हैं. तो ये जितना फोर्स इस पे लगेगा ये भी उतना ही फोर्स लगेगा. तो नॉर्मल कितना होगा दोनों के बीच में? 0. बिकॉज ब्लॉक्स आर नॉट प्रेसिंग ईच अदर ना. ये दोनों अपने आप पे प्रेस नहीं कर रहे. एक प्रेस किस पे कर रहे हैं? अगर 2 kg ब्लॉक मैं ग्राउंड पे रखूंगा तो 2 kg ब्लॉक क्या ग्राउंड पे लगेगा कि 3 kg पे लगेगा?
ग्राउंड.
ग्राउंड पे लगेगा। तो 2 kg प्रेस किसको कर रहा है? फ्लोर को प्रेस कर रहा है, 3 kg को प्रेस नहीं कर रहा है। So I
फिर
can
जब
write here right now, isn't it? So is that point clear? So I can say here
एक
right
दूसरे
now,
को प्रेस करे तो क्या होता?
मतलब प्रेस करे तो जब अगर मोशन में आ जाएंगे ना बेटा, अब ये 3 kg है, 2 kg है, अगर अब देखो अगर आप 80 kg के हो, अगर मान के चलो आपका दोस्त एक 30 kg का है, अगर आप इस पे फोर्स कर रहा है, ये पे आपको फोर्स एक्सर्ट कर रहा है, तो गिरने के चांसेस किसके ज्यादा है?
30 kgs वाले का।
30 kg का पर्सन ज्यादा करेगा, यानी जब एक्सेलरेशन आ जाएगा बॉडी पे,
यस सर,
isn't it?
Yes.
तो यू विल बी हैविंग ए नॉर्मल। लेकिन अब यहाँ पर क्या रखे, आप मान के चलो आप बैठे हो एक कुर्सी पे और आपके साथ आपका दोस्त भी बैठा हो, आप सिर्फ खंदा खंदा लगा के बैठे हो, बस ऐसी, बस क्लास बहुत फुल है, मान के चलो आप एक को एक खाली चिपक के बैठे हो, तो आपका वेट जो है ना चेयर के ऊपर से नीचे जाएगा कि आप अपना वेट पूरा इस बॉडी पे डालोगे, ये अपनी फोर्स इस पे बॉडी पे डालेगी। आप जब बैठ रहे हो तो आपका फोर्स पूरा ग्राउंड पे एक्सर्ट करेगा ना बेटा,
यस सर,
ये भी अपना फोर्स नीचे है, यानी प्रेस किस पे कर रहे हो आप? Isn't it? You are
Ground.
pressing on the ground. This is also pressing on the ground. So this 2 kg of the body is pressing on the ground. This 3 kg block is also pressing on the ground. But 2 kg is not pressing to 3 kg and 3 kg is not pressing to the 2 kg. खाली वो दोनों खाली ऐसे attach होके बैठे हुए हैं. So I can say that blocks are not pressing each other. ठीक है ना? तो नॉर्मल क्या हो जाएगा उन दोनों के बीच में? 0. क्लियर है? चलो और एक क्वेश्चन ले लो, विल गेट मच क्लैरिटी ऑफ दिस वन। मान के चलो वी हैव गॉट 2 ब्लॉक्स, अब जरा सोच के बोलना, वी गॉट 2 ब्लॉक्स ऑफ मास m1 and m2, m1 and m2 are kept in contact on a smooth table, smooth table मतलब चिकना टेबल पे, so that it can slide very easily on a smooth table, friction नहीं है। If force capital F is applied, on the blocks as shown, find the acceleration अब तक अपने जो फॉर्मूला आया खाली न्यूटन सेकंड लॉ से F इक्वल टू ma है, उसी से हम लोग को निकालना है। फाइंड द एक्सेलरेशन ऑफ both the blocks and normal force between the blocks। क्वेश्चन अच्छी तरह से समझो पहले, ठीक है? तो इसका मैं डायग्राम बता रहा हूँ, देखो डायग्राम इस तरह से दे रखा है, ये मेरे पास ग्राउंड है, ठीक है? इस पे यहाँ पर एक ब्लॉक है, तो ये हो गया वेट ऑफ द ब्लॉक m1, ये हो गया m2, और इस पे हम लोग फोर्स लगा रहे हैं, कोई धक्का दे रहा है F, तो जब धक्का देगा तो पूरा सिस्टम सामने भागेगा विद एन एक्सेलरेशन। अब क्वेश्चन को समझो, वी हैव गॉट 2 ब्लॉक्स ऑफ मासेस m1 and m2, मान के चलो 2 बॉडीज ऐसे खाली बैठे हुए हैं, सडनली कोई इसको अगर फोर्स लगा तो क्या m1 इस पे फोर्स एक्सर्ट करेगा? नीचे पूरा चिकना है, पूरा फिसलने का बंडा है, जैसे एयरपोर्ट पे समझो, एयरपोर्ट पे अगर आपने कभी ट्रैवल किया होगा तो अगर ट्रॉली में अगर आप शायद इतना भी लगेज लगा दो, अब छोटा सा भी फोर्स लगाओगे तो ये बॉडी सामने भाग जाएगा, थर्ड भागेगा कि नहीं भागेगा? क्योंकि जो फ्लोरिंग होता है एयरपोर्ट का आपने देखा होगा बहुत ही ज्यादा चिकना होता है, फ्रिक्शन ऑलमोस्ट 0 हो जाता है उसको, है कि नहीं? फिसलने के चांसेस बहुत ज्यादा होते हैं। So this one is of your frictionless surface. This one is your frictionless surface. This one is your frictionless surface. यानी if I am exerting the force, आप फोर्स किस पे एक्सर्ट कर रहे हो? m1 पे, m2 पे तो आप नहीं कर रहे हो ना, तो m2 पे कौन फोर्स एक्सर्ट करेगा? m1 करेगा, है कि नहीं? m1 इस पे फोर्स एक्सर्ट करेगा और m2 भी इस पे फोर्स एक्सर्ट करेगा, ठीक है नहीं? दोनों कांटेक्ट में कंडीशन हो जाएंगे. सो व्हाट इज द नॉर्मल फोर्स बिटवीन देम बेसिकली गिवन कंडीशन. मैंने बोला अगर ये दोनों कभी भी कांटेक्ट में रहेंगे, ये जितना फोर्स इससे एक्सर्ट करेगा ये भी उतना ही फोर्स इस पे एक्सर्ट करेगा. बोला था कि नहीं बोला था बेटा? ये दोनों कांटेक्ट में
Yes,
है
sir, बोला.
तो ये अगर 10 न्यूटन इस पे एक्सर्ट करेगा, m2 भी 10 न्यूटन इस पे एक्सर्ट करेगा. अगर ये दोनों फोर्स सेम है तो ही ये इन दोनों की कांटेक्ट बने रहेगी. अगर दोनों के बीच में कोई फोर्स अगर कम ज्यादा हो गई तो ये छूटने के ज्यादा चांसेस हो जाएंगे. ठीक है ना? अब एफबीडी बताओ जल्दी से. इसका कौन बताता? देखो मैं देखो क्लियरली लिख रहा हूँ एक एक बॉडी के लिए. मैं मान के चलो फर्स्ट बॉडी ले लिया m1. m1 पे कौन कौन फोर्स एक्सर्ट कर रहे हैं? आपने फोर्स लगा दिया F, तो अब ये सामने भागना शुरू करा विद एन एक्सेलरेशन ये, और m2 ने इस पे ऑपोजिट फोर्स लगा दिया, ये हो गया ये. और यहाँ पर है मेरे पास m2. m2 पे कौन फोर्स एक्सर्ट कर रहा है? खाली m1 फोर्स एक्सर्ट कर रहा है. वो कितना एक्सर्ट कर रहा है? n2 एक्सर्ट कर रहा है. और ये भी सामने भागने की कोशिश कर रहा है विद एन एक्सेलरेशन ये, क्योंकि इन दोनों के बीच में नॉर्मल सेम है ना. ये n2 है और ये भी n2 है. ठीक है ना? या दोनों के बीच में nn ले लो बेसिकली, कोई प्रॉब्लम नहीं. ठीक है ना? ये इसको भी n मान के चलो और इसको भी n मान के चलो. अब F1 पे बताओ फोर्सेस क्या लग रहे हैं? F1 पे बताओ फोर्सेस क्या लग रहे हैं फॉर M1, फॉर ब्लॉक M1? बताओ. एक तो फोर्स सामने लग रहा और एक फोर्स पीछे लग रहा है. कितना? n. फोर्स मस्ट बी इक्वल टू मास इनटू एक्सेलरेशन from Newton's second law. F net must be equal to net force must be equal to mass into acceleration. Net force क्या क्या है? देखो F1 पे क्या M1 पे क्या क्या फोर्सेस लग रहे हैं? पॉजिटिव एक्स एक्सिस में F लग रहा है और नेगेटिव एक्स एक्सिस में n लग रहा है. तो पॉजिटिव फोर्स पहले लिखो, नेगेटिव फोर्स बाद में. तो F माइनस कैपिटल F माइनस स्मॉल f इज इक्वल टू मास ऑफ बॉडी पे कितना? m1 इनटू योर एक्सेलरेशन. ये निकला सभी को? निकला
Yes,
सभी
sir.
को? तो इसमें से अभी नॉर्मल निकालना है. नॉर्मल निकालो, कैसा हो जाएगा बताओ? n विल बी इक्वल टू कैपिटल N इज इक्वल टू ये बन जाएगा F माइनस m1 इंटू योर ये. निकला सभी को? n की वैल्यू निकली सभी को?
Yes, sir.
ठीक है. सो द सेम वे फॉर ब्लॉक m2. अब बताओ ब्लॉक m2 पे कितने फोर्सेस लग रहे हैं? ये देखो m2 पे कितने फोर्सेस लग रहे हैं? बताओ जल्दी से. खाली n लग रहा है ना?
एक एक.
Yes.
n इज इक्वल टू m2 इंटू योर ये, क्योंकि मूव कर रहा है. सो n विल बी इक्वल टू योर m2 इंटू योर ये हो गया नॉर्मल इसमें. ठीक है ना? फॉर m1 नॉर्मल कितना है? f माइनस m1 इंटू ये है. फॉर ब्लॉक m2 ये नॉर्मल कितना है? m2 इंटू योर ये है. ठीक है? ये दोनों की वैल्यू सेम आना चाहिए. अब देखो कैसा करना है. दोनों की वैल्यू अपने को सेम आना है. अब देखो क्या करना है अपने को. यहाँ पर ये देखो, ये दोनों क्या सामने सेम डायरेक्शन में जा रहे हैं? तो दोनों मिलके जा रहे हैं ना, तो फोर्स कितना हो जाएगा?